This is Chapter 9, Problem 5. In this problem, we're tasked with finding the center of mass of this system, which consists of 4 uniform slabs, so made up of the same material. And if you look at it, it kind of looks pretty complicated. It's like, where do we really start with this problem? So for starters, what we're going to do is we're going to figure out the center of mass for each individual slab. You'll see that I have each slab numbered according to a Roman numeral, and I did my best to draw the picture. Yeah, I'm not really that great an artist, just bear with me here a little bit. So starting out with the first slab, you can imagine on the xy axis that the x component of its center of mass is at negative L, because it is to the left of the x-axis, or to the left of the y-axis, excuse me. The y component is going to be 3L over 2. Again, the center of mass is going to be at the center of the object, so it's going to be at the center along the x and the center along the y. Moving on to the second slab. The second slab has an x component of minus L and a y component of minus 2L. The third slab has an x component of L and a y component of negative 3L. And the fourth slab has an x component of 2L and a y component of 2 1/2 L. Now from here we have to think very carefully about how we're going to model the mass for each one of these slabs. Since the slabs are all uniform, we can base the mass off of the area of each slab. If you have more area, then that means you have more mass. So that would mean that the first slab has a mass of 3L times 2L. 3L times 2L. The second slab has a mass of 4L times 2L. The third slab has a mass of 2L times 2L. And finally, the fourth slab has a mass of 4L times L. So you're going to use this to figure out the total mass of your system. And each of those individual masses for each individual slab will be used in the center of mass equation on the next page. Picking up where we left off, we have 1 over the total mass of the system, which is 6L squared plus 8L squared plus 4L squared plus 4L squared. Now we need to multiply by each of those individual masses for each slab, multiplied by the x component of its center of mass, because that's the component we're dealing with. So for the first mass, it's 6 multiplied by minus L. Second mass, 8 multiplied by minus L. Sorry, this is going to get a little messy. Plus 4 times L plus 4 times 2L. You'll notice that you'll have 1L cancel in the denominator of your problem, so you need to do the sum of 6, minus 8, 4, and 8, and then divide by the total mass all multiplied by L. And with a little bit of math, you should get that the x component of the center of mass is equal to negative 0.45 centimeters. We can do the exact same thing for the y component of the center of mass. For the y component center of mass, we once again have the exact same denominator, which is 1 over 22L squared. That's 6 plus 8 plus 4 plus 4. And now we multiply by the masses multiplied by the y components of the center of mass. That's going to be 8 times minus 2L plus 6 multiplied by 3L over 2 plus 4 times minus 3L plus 4 times 5L over 2. And finally, you get a y component of the center of mass equal to minus 2 centimeters. So again, a lot of math in this problem, but the things to keep in mind: you want to find the center of mass coordinate for each individual slab. Then you want to treat each slab as a mass based off of the size of its area, and that will determine which total mass you should use for the whole problem. And that's it.